Good day guys, welcome to today's video. In today's video we are going to talk about ultrasonic sensor. If you look at the screen, you will see the ultrasonic sensor. It is called the HCXR04. So this is the ultrasonic sensor and it has 4 pins, which is VCC, the trigger pin, the echo pin and the ground. So I will explain how this ultrasonic sensor works. And this sensor is used to measure distance. So you can use this sensor to measure the distance of an object. And this sensor comes with two transducers, which is the transmitter and the receiver. So how this ultrasonic sensor works is that whenever you send a pulse through this trigger pin, this transmitter transducer will emit an ultrasonic sound of 40 kilohertz through this transmitter. And whenever you can see it over here, whenever it hits an object, that sound will reflect back to the receiver, and the receiver will receive it and send the information through this echo pin. Okay, so how it measures the distance is like this. Whenever you send a pulse through this trigger pin, this transmitter here will emit 40 kilohertz ultrasonic sound, which is this wave we are seeing over here. This wave will travel. Depending how close the object is, will determine the distance, the time it travels. So if the object is far, and when this ultrasonic sound travels and hit the object to reflect back to the receiver, that is how the time which the ultrasonic sensor travels in the speed of sound before sending back the signal back to the receiver, is how we calculate the distance. Okay, so this is the illustration on how this thing works, and this thing has a formula on which we use to calculate the distance. Okay, so let me take you to our simulator and show you the formula for calculating the distance. Okay, so how to calculate the distance is this. This is the formula for calculating the distance. This D means the distance, while this T means the time which that ultrasonic sensor travels. Okay, the time which it takes to travel times the speed of sound divided by 2. Okay, so this T means the time which it travels, while this S means the speed of sound, which is constant, which is 340 meters per second. So if you want to convert it to centimeter, that means it will be 0.034 centimeter per microseconds. Okay, it depends. If you want to convert it to centimeter, that means you are going to use 0.034 centimeter per microseconds. But the actual value, the way it works is that the time times the speed of sound, which is 340 meters per second, you divide it by 2. That is how we measure the distance. Okay, so I'm going to take you to the code and see how we do it. But first of all, let me show you something. In real life, the reason for this resistor here is used for measuring the distance. You can see that this is a simulator. You can't use an object and place it in this simulator. That's why the people that manufacture this, that created this component in this Pro Tools, put a test pin on it, so that you use the resistor, the port resistor, as an object that it will measure the distance. Okay, and this is the pin. This is the 5 volts, which is the VCC, the trigger pin for the input for this transmitter. The echo pin is the output from this receiver. So in how we are going to set it up in our Arduino is that we are going to make one pin of our Arduino as an output, and that output is going to go to this trigger pin, because we are going to send a signal through this trigger pin. Okay, the trigger pin for this sensor is the input, while the echo pin for this sensor is the output. But since we are using Arduino to send that pulse that pulse, we are going to make pin 9 as an output, because we are going to use this pin 9 to send in that pulse that this trigger pin needs. Then we use the echo pin, which is the output of this sensor. We are going to make pin 7 as input for the Arduino. This input will take the output of this sensor and we do the calculation inside our code. Okay, remember this port here is for testing the distance. So I'm going to go to Arduino code and show you something. But before that, I'm going to point out something. Before you can use this thing in this Pro Tools simulator, there is this hex file that you need to bond to this sensor for you to use it. If not, it won't give you the access to use this sensor in the Pro Tools. So I'm going to provide you the necessary materials for it. So but before that, let me show you. Okay, I said before that, let me show you how to add that the hex file for that ultrasonic sensor. So this is the material here. This is the zip file. Once you extract it, you just open the folder. If you don't have the sensor, you can add the sensor into your library, but this is not what you're talking about, because I believe that we already have the sensor in our Pro Tools. But what I'm pointing out here is the sensor hex file, which is this thing now. You can see it. This is the hex file for that sensor, for Pro Tools to allow you to use the sensor. So what you're going to do is just to right click and copy the hex file. Then you go to your desktop location, then go to program file 86 if you are making use of 64-bit system. Click on it, then go to Lab Central Electronics, which is this folder. Then this is Pro Tools 8 Professional. Open the folder, then go to this folder here called bin. Open the bin, then and paste the file. I've already pasted the hex file. So you paste the hex file that you copy from the material that I shared and paste it in this bin folder. Then after that, you can go to our Pro Tools simulator, double click on this sensor. It will show you to pick this. It will show you ultrasonic sensor hex file. Then click on this folder. Once you click on this folder, go to the Arduino. Go to the Arduino, the Pro Tools Professional folder on your desktop. Okay, so go there. This is it. Then go to Lab Central Electronics. Go to okay. Then click on bin. You will see this ultrasonic sensor tep.hex. Then click on it and open it. Once you are done, click OK. If not, Pro Tools won't allow you to use this sensor. Okay, so let's go to our code, our IDE, and show you how we do the coding. Okay, so first of all, we declare a global variable, which I use data type int. So this is the trigger pin, which is pin 9 for the trigger pin, then pin 7 for the echo pin. Then we declare a variable using long data type to declare duration and distance. This is where we are going to store the calculation that we are going to do in this our coding. Okay, then you go to voice setup. Under voice setup, you initialize your serial port, okay, which is serial.begin. Then you put in the 9600 baud rate. Then we use our pin mode. The trigger pin, we set our trigger pin as output, which is this pin 9 as our output. Then set our echo pin as an input to receive the signal from the receiver of the sensor. Okay, so after we are done doing that in the setup section, we go to the void loop. Under this void loop, we use digital write and set the trigger pin, and you know that our trigger pin is pin 9. We set our pin 9 low. Then we use a delay microseconds. I will still discuss about this delay microseconds. Okay, I will still discuss about it, but this delay microseconds, the name explains itself. Delay microsecond means a delay of a microseconds. Normal delay use in millis, normal delay use milliseconds, but this one is microseconds. Okay, if you want to delay a time in microseconds, you use the delay microseconds function. So we set the trigger pin low, then we delay it for 2 microseconds, then we use the digital write to set the pin high. So we are going to set that trigger pin, we are going to send in a pulse of 10 microseconds. That pulse of 10 microseconds is going to generate 40 kilohertz ultrasonic sound. So that is what we are going to do here. Okay, we need a pulse of 10 microseconds, just a pulse of 10 microseconds. That is what we need. So we use trigger pin, we set the trigger pin high, then we use delay microseconds 10. Remember I said it's 10 microseconds pulse that we need. We use the delay microseconds, which is 10 microseconds. Then we now set the digital, we now use the digital write to set that the same trigger pin low, because you know how pulse works. Pulse is low and high. Okay, that is a sign of pulse, sending a pulse. Whenever we talk about pulse, we mean a signal that is going high and low for a certain duration. Okay, that is what we did. That is what we did here. Then under this, we use that our variable, which is duration, and we now use a pulse in function. Arduino pulse in function. What this pulse in function does is that you will use it to detect a pulse that is being sent. We use this pulse in, just like the name implies, pulse in. It will just stand to listen to detect if there is any pulse. So that is what we are doing. And this pulse in functions takes 2 parameters: the pin that you want it to detect the pulse, and whether you want to detect a low pulse or a high pulse. So what we want to detect is whenever that pin will send a high pulse. Okay, that is why we set it as high. You can look, you see it here. We set it high because we want to detect a high pulse, not a low pulse. You can detect a low pulse or high pulse depending on you, but this pulse in function is used for detecting pulse. Okay, so under this pulse in function, we calculate the time. That is the time the echo pin sends the receive ultrasonic sound. Okay, that is why we use this pulse in function. Then under it, we use the distance, that our distance variable that we just declare. We now brought in our mathematics. Remember, the calculation for calculating the distance is the time which that ultrasonic sensor travels times the speed of sound divided by 2, and this duration is what holds that time. This duration is what holds that time. That's why we use the pulse in. So under this distance, we are doing that our calculation. This distance we hold the value of that our calculation. So we now call duration. Duration means that time that this pulse in detects that pulse which is being received from that our receiver. So it will receive that signal. Okay, so the duration is this. Duration is what is holding this time that the receiver pin of that sensor send in the pulse. So we now times it by the speed of sound, which is 0.034 centimeter. We are converting to centimeter. Okay, then we divide it by 2. So under it, we use the serial print to print the distance using that our formula. Okay, so remember that this pulse in is what listens to our echo pin to know when that our receiver from that sensor receive the reflected sound of that ultrasonic sensor. So once it receives that sound back, it will send it through the echo pin, and this pulse in function will just stand to listen to this the pulse that it receives. So whenever it receives that pulse, that means is the time which that ultrasonic sensor travels. Then we times that time by the speed of sound divided by 2, we get our distance. Okay, so that is it about this code. So let me go to our Pro Tools simulator so that you will see how it measures the distance. Okay, so let me go to our Pro Tools simulator. and let's simulate. So I'm going to simulate it now. So we are going to simulate it. So let's wait while the Pro Tools is simulating it. Okay, see it here. This is our virtual terminal. So I'm going to use this port to adjust our distance, to adjust what we are sensing. If you look at the virtual terminal, you will see the distance in centimeter. This is the distance that this ultrasonic sensor is sensing based on the position of our port. So if I try to reduce it now, you see that it will adjust the value that is sensing. Just look at the virtual terminal, you see that the distance is adjusting. So we are using this port to adjust the distance, the object that the sensor is detecting. But if it is actual real life, we don't need we don't need a port. We can use it just to detect any object. So we are just using this port for simulation purposes to test the distance, because you can see the way the sensor is in this approach. You can't put any object in front of it. That's why they make the provision for that pin, so that you use a port to detect the distance. So whenever I adjust the port, you see that the distance will also adjust. Okay, look at it now. It is adjusting. The value is adjusting. The value is adjusting. The value is adjusting. So you can see it. You can see it. So whenever we bring our resistor down, you see the value that is showing. Okay, so if I try to bring it up again, you see that the value will also increase. You see it, the value is increasing. So guys, this is how to use the ultrasonic sensor. Okay, see you in our next video. Bye.